Welcome to another class. Thank you so much for being here. Um, I'd like to start with some issue with the department. So the domain account I introduced to you last time and the syllabus I went over last time, there has been a few changes on these things. So we are not going to use the old the new because the department changed their mind about old book and new book. So we're going to use the old book and you'll get it's echoing. Okay, let me see what's wrong with this. Oh. Oh. Can you hear me now? Is it better?
Yes.
Okay. How so I can hear myself? Okay. Yeah. So, wait, hold on, the microphone is not working. Give me 1 second. What's wrong with the microphone? Okay, now let me just put the microphone here. So, what I was saying? Oh, the old book, new book. So there have been few things going on with the department, so they decided to let you use the old book this semester, but the student who is gonna take the class next semester, they must have to use the new book. So all the things changes I made on Lumen, I had to throw out my Lumen account and I had to create a new Lumen account and I had to modify my lecture notes again. So the Lumen account I introduced you to the last time, you cannot enroll in that account anymore. You have to enroll in a new account. So that reminded me, let me go to our syllabus. So I actually posted a new syllabus on Brightspace and I highlighted all the changes I made in the new syllabus. So in the new syllabus, you see here, in the old syllabus, it says book was different, but in the new syllabus, I said, well, we're going to use this book, not the new one. And also, even though the enrollment key is the same, but the course ID is actually different. Okay. And in the old syllabus, all these sections here, they are different. So I highlighted all the new sections that I'm going to cover with you guys. Good news is that chapter 1 and up to 2.5, there are same materials. So the old syllabus, new syllabus, they have the same materials for exam 1, but all the materials for exam 2 and 3 has been changed, and I'm going to follow this new syllabus. Okay. So if you haven't enrolled in the Lumen account yet, please do so ASAP. With this ID code and this enrollment key. Again, the enrollment key is same, but the ID code are not same. They're different. So let me introduce you to Lumen again. Lumen. So when you go to Lumen, in order to enroll, let me log out. So if you are taking this class for the first time, you didn't see me in our last class, then in order to enroll in the Lumen, first you go to Lumen account, Lumen on the .com, and then you go to enroll in a new course. And then they're asking for the course ID and enrollment key. So in the syllabus, I gave you both of them. This is the ID. You're going to copy and paste here. And same thing, you are going to copy and paste the key. And then you click on enroll. And then you see my name, this is my name, and this is our course. You're going to click on enroll. Once you click it, then either you have to log in with your own username and password if you used it before. If you haven't, then you have to make a new account. Make a new account and then click on submit, and then it will take you to our Lumen page. Now, once you register, then next time you don't enroll again, you just click on login. Once you log in, you're going to see this class. So let me go to student view. Okay. So you're going to see your gradebook on the left and all these things here. So usually the first thing looks like this. Okay, everything is in closed version. So here is this course syllabus. I actually don't have the syllabus here because I uploaded on Brightspace. And you click on chapter 1 to drop down to get the drop down menu. And then you see 1.3, 1.4, 5, and 6 from chapter 1. Now, the first thing you notice is these are video lectures. So if you want to see something, you can simply click on each one of them, and then you'll see the video based on those topics. And if you don't need any videos, you can simply go to the homework. You click on the homework, and then you click, it will say start. In my case, it's saying resume because I already clicked before. So here it says 10 possible points. Probably they had 10 questions or 15 questions. I don't remember. But once you click on the homework, I believe you have unlimited attempts, unlimited time for homework. But for quiz, you have to take also quiz. Quiz is not unlimited time. The quiz is 2 hours or 3 hours. I don't remember exactly. And the due date, it says 5/15. That's because I didn't change anything yet. So last time I did change some of them, and then I modified many things inside, and then the department said, oh, you're not going to use it. So I was like, well, let me wait till few more days and see if department change their minds again. So that's why I didn't change anything yet, but eventually I'm going to change all the due dates. So my plan is to change the due dates every week based on how much materials we cover in class. For example, whatever we're going to cover today and Wednesday, those materials, they will have those sections, they will have due date probably next week, Sunday midnight or Monday midnight, something like that. So the due date I'm going to change, but you don't have to wait for the due date to do your homework. You can always do homework anytime you want before the deadline. Okay. So there are 4 sections in chapter 1, and I will not actually follow the order. I'm going to follow the content. So in our last class, we started limits. So I'm going to follow all the limit content. So maybe some will be from 1.3, some will be from 1.5, some will be from 1.6, and some will be from 1.4. Like then they're not in order, but since homework has unlimited attempts, so you can always try whatever you see in any of the 4 homework. Okay. So I'm going to put that deadline for this for homework probably next week. So I think we'll be able to finish the limit concept in 3 lectures. So after 3 lectures, you're going to have them due dates. And once you're done in chapter 1, you're going to take quiz 1. Now, if you were not in our last class, our grading policy is that 80% exam. So you're going to have 3 in-class exams, 80 classes, 3 in-class exam plus the final. So combining all of these, 80%, and then the Lumen quiz I just showed you, that Lumen quiz, plus your attendance and class participation, combining all of them at 10%. And the homework I just showed you, that homework is 10%. So Lumen is 20% and exam is 80%. Within the Lumen, you also have your attendance. So make sure you attend every class. I want to take attendance, and then every attendance counts as 1 point. So with the Lumen quiz score, I'm going to add your attendance score. Plus, anytime you class participate, I'll consider that also. And at the end of the semester, I'm going to use this table to assign you a letter grade. If you have that option, sometimes we don't have that option. So if you guys don't have that option, that means you have either pass or fail concept. Or if you have the letter grade option, then I'm going to use that. And this is actually a modified version. Also in my the grade not grade the syllabus I uploaded on Brightspace, it has another thingy table which says specifically few days it will be online, and then most of the days you will be in person, and the online classes will be only on Mondays. Okay, not every Monday, but few days I have to attend conferences, so I cannot be in person in Hunter. So I'll give you lecture from Colombia or somewhere wherever I will be um uh to you guys the lecture. What else? What else? Oh, Brightspace. So on Brightspace, in order to access our page on Brightspace, uh, 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 the main thing you're going to see, the first thing you're going to see is the announcement. So anytime I have something to tell you, please check your email or announcement. So let's say someday you didn't see me in class, and then you may wonder, well, is today online or in person? Check your email and check your thingy announcement. Anything happen, if anything happen, I'm going to tell you before class that something suddenly this happened. So it's better to always check your Brightspace announcement and also email. Sometimes I can't access my Brightspace, so when I cannot access, I can actually send you the email from CUNY first. So either I'm going to email you, or I'm going to send as an announcement whenever I have something to tell you. And the next important thing here is content. So under content, see, I posted updated syllabus and then class recording playlist. I don't have it here, but let me actually do it right now. I was waiting for today's class to have it. So our class with a playlist. So all the class we are going to attend, my plan is to record them and then make them available here. So from our last class, I omitted many things because they don't apply any longer. So I made it shorter here, the first video. But today's video, it will be below that. And to access that, you can upload. Okay, so in order to access all the recording, you can simply go to class recording tab on the left, and then you see the link. You click on the link, it will take you to this page. Okay, so anytime you miss a lecture or you want to revisit the lecture, you can always come back here to rewatch whatever you missed during lecture. And also, I'm going to give you a review sheet before exam. So the review sheet will be here. Pre-lecture notes, I intended to do it, but see, I'm making all the sections together. So for chapter 1, I'm still organizing my material, so I didn't post anything here. But once I have everything organized, then I'm going to post the lecture notes, which I will go over in class ahead of time in here. So if you want to print them, you can print them out, or if you want to use tablet to write them on only, you can use that. So for today, I don't have it, but hopefully I will have something before Wednesday. Hopefully, if I can make if I can organize everything the way I want to. Okay, I talked for how much minutes? Almost 20 minutes. So, any question? Any comments, concern, complaint, anything? Nothing? Thank you. Okay, then let's go to our lecture. So, chapter 1, I'm going to cover 1.3, 1.45, and 6. And as you can see, all of them are mostly related to limits. So limit is a function, calculating limit involving infinity and continuity. So my plan is to combine 1.3, 4, and 6 together because they all are specifically based on limits, and then lastly introduce you to continuity. Okay. So in our last class, we talked about what is limit and why do we care? So limit is the y value, okay? We look at a smaller neighborhood around some x value, and we see around that neighborhood for the x values how y are changing. Is y going toward a specific number, or they're going toward different numbers? So if they are going toward the same specific number, we say, well, the limit is that number. And if they go around different numbers, then we say the limit doesn't exist. So there are several types of scenario where the limits exist differently, and sometimes limit doesn't even exist. So in other words, limit, if you say the word limit, it's specifically asking you, give them the y value based on the looking at the x values. So I'm going to start here. It is all lecture 2. Oh, oops. It is lecture 2. And it's 2, 3, 25. So in our last class, we did one example with sin x over x. And we observed, we observed both graphically and pointwise. So if you look at pointwise, we are looking at the x value near 0. So it's like it's 1, 0.5, 0.4, 0.3. Like how, if you go to 0 from your left side and from the right side, how the y values are changing. Is it going toward a specific number or not? So if you observe, it doesn't matter which direction you are going, either -1 or +1 for both x values. This is the y. For -0.5 or +0.5, it doesn't matter for that number. For both of them, this is our y value. So as you can see, the y values are getting bigger, bigger, and bigger, and they're going approximately toward 1. Now, if you observe the graphic, the graph, you'll see that our x value is 0 here. So we are looking at a close neighborhood, which is closer to 0. And we see in that neighborhood how the y values are changing. So when you walk your function, you see around, for this x value, we have the y value here. For this x value, we have the y value here. So for this neighborhood of 0, our y value is around the neighborhood of 1, the y value 1. So we can see graphically that when x is getting closer to 0 from both direction, our y value is getting closer to 1 from both direction. That's why our limit is 1. Limit means the y value of the function. Now, not always limit exists. So for example, if you see this function, it's called Heaviside function. This function, it says it's a piecewise function, okay? It says our y value is 0 when all the x values are smaller than 0. So y value is 0 for all the numbers, for all the x values are smaller than 0. So x is -1, -2. Y value is 1 for all the values, for all the x values bigger than 0 or equal to 0. So when x is 0, our y value is 1. Also, when our x value is bigger than 0, like 1, 2, 3, let's say up to 100 and 1000, much more than that. For all these x values, our y value is always 1. Now, this function doesn't have a limit. Why not? Because, doesn't have a limit at 0. Why not? Because when you are in the neighborhood of 0, look at the left side. The left side is giving you the y value 0. But look at the right side. For this neighborhood, we have our y value here. Now our y value is closer to 1. Y value is 1 when our x values are bigger than 1, bigger than 0. When x is bigger than 0, our y value is 1. But when x is smaller than 0, our y value is 0. So at x equals 0, we have two different y values. They are not same y values. Since we don't have the same y values on the left side and also on the right side for the same x value, so we don't have the limit here. The limit doesn't exist. This concept takes us to one-sided limit. Even though a function may not exist, the limit may not exist at a particular point, but one-sided limit always exists for every point in the function. It may not be a number, it may be infinity or negative infinity, or could be a number, but the limit, the one-sided limit, always exists. Okay, so what does one-sided limit mean? One-sided limit means you're looking at your y values from only one side. That is called one-sided. So we write limit x goes to a particular number, and then we put either a plus sign or a minus sign on the top. If you put a minus sign on the top, that means you're observing the x values from the left of that number. For example, the Heaviside function. So we have, this is, now here, if you look at limit x goes to 0 and then a minus sign on the top of f of x, it means observe your function from the left side. This minus means left side of your limiting value. The number you have next to the x under limit is called limiting value. So we are observing our limiting value from the left side. And then we see what is happening to the y value. So when you observe a one-sided limit on the left side, our y value is going toward 0. So y value is 0 for all the left side points of 0. Similarly, if you look at limit x is going to 0 and then a plus sign above it. It means you are looking at your function. You're looking at your function x equals 0. This is x equals 0. You're observing for all the x value bigger than 0. So all the x value bigger than 0 is on the right side. For them, our y values are here on the top, which is 1. So in here, our y value is 1. But in here, the one-sided limit is 0. So when you walk toward 0 from the left side, negative means left. When you walk toward 0 from your left side, you observe the y value, or y value is 0. On the other hand, when you walk toward 0 from your right side, so we walk on the x-axis, but we actually observe the y-axis, the function. So when you walk to 0 from your right side on the x-axis, the y values are going toward the y value 1. So that's why our right side limit is 1, but our left side limit is 0. That's why the limit doesn't exist, because in order for a limit to exist, the left side limit must be the same number as the right side limit. They have to have the exact same thing. If the y values are number, then they have to be the same number. If the y values are infinity, then they have to have the same infinity. So usually the limit exists everywhere in the function, except in few cases. One of the cases, jump. When you have a jump in the function, the limit doesn't exist. For example, here in the Heaviside function, your y value is 0, 0, 0, 0, and suddenly you jump to 1, and then now your y values are always 1, 1, 1, 1, 1. So there's a jump at 0, x value 0. So when you have a jump, the limit doesn't exist. When there is a hole, the limit is the y value that would fill the hole. So when you have a hole in the function, at that time, the limit actually does exist. The limit doesn't exist at a jump, but when you have a hole, the limit does exist. Okay, what does hole mean? Let's say you have a function something like this. Okay, so if you walk toward that number from your right side, you see your y value is here. If you walk towards that number from your left side, you have the same y value. You are walking toward the same y value from both directions. That's why the limit does exist, because the left side limit and right side limit, they are the exact same y value. So in here, the limit does exist. The y value doesn't exist for this function because we are hole there, but the limit does exist because the one-sided limits, they are same. Okay, so here we are going to 0 from minus side. Minus side means left side. So when you are walking towards 0 from the left side, your function is going toward the y value 0. So here our limit is 0. On the other hand, this means you're walking toward the right side. From the right side, sorry. So when you walk from the right side, look at the y values. The y values are getting closer and closer to the y value 1. So our right side limit is 1 here, when the left side limit is 0. Since left side limit and right side limit, the limit x goes to 0 from the left is not same as limit x is going to 0 from the right. They're not same, so the exact limit doesn't exist. One-sided limit exists, but the exact limit doesn't exist because the one-sided limits are not same. Any questions so far? Was anything confusing? All good? Wonderful. If you have any question anytime, please don't hesitate. Don't feel shy. Don't think I will laugh at you. Definitely I will not. And don't think you're asking me any silly question. It doesn't matter how silly you think a question is, but I'm really happy to get them. Okay. So don't hesitate. Does piecewise function have a limit? Yes. They definitely have one-sided limit. And if the two-sided limit are same, then they have a limit. So we are going to work with piecewise function. This piecewise function doesn't have a limit because the left limit is not equal to right limit. See, exactly at 0, the limit doesn't exist because the left side y value doesn't match the right side y value. They're two different y values. Now let's do some fun example. In this example, the blue one, we are finding x is going to 2 from the left side. So let me actually write this bigger. X is going to 2 from the left side of this function. So this is our x value 2. You are observing the y value from the left side. So this is our y values. All of these are y values. When you're walking toward the x value, how the y values are going, which direction, for which number? What do you see in the function? When you are approaching to the x value 2, what is your y value? There is a jump, true, but what's the y value you're going towards? Good job, it's 3. See, the y value is 3. So on the left side limit is 3. The next one is asking the same question, but this time you're walking from the right side. So you're walking from the right side on the x and you're observing the y. So if you're observing the y for the x value 2, great. It's 1. Wonderful, guys. So the last one is asking, well, based on the left side limit and right side limit, what can you say about the limit exactly at 2? It doesn't exist because the left y value doesn't match the right y value. It has a jump. Because of the jump, the exact limit doesn't exist. So when you don't have any plus sign or minus sign on the top, it means exactly at 2. Exactly at 2. X value 2, I should write. Exactly at x equals 2. So when you look at exactly at x equals 2, see, at 2, we have two different y values. One y value is 1, the other y value is 3. They don't match, so limit doesn't exist. Now, do you guys understand what I was talking all these times? Is there anybody who is confused? Don't be shy, please. Just let me know if you have any question. Any question? No question? Okay. Then to this one. You are looking at the limit. X is going to 5 from the left side. This is 5. X is going to 5 from the right side. And exactly at 5, what's the y value? Okay, so look at 5. This is 5. Now, when you're walking to 5 from your left side, minus means the left side. When you're walking toward 5 from your left side, where are all the y values going? What is the y value we have? 2. Great. The next question is saying, go to 5 from your right side. So this is our right side. That means you're observing the function from the right side. We still have the same 2. I understand, Andy. So you still have the same 2. That means what is happening exactly at 5? This time, do we have a limit? What is the exact limit at 5? Yes, we do. So what is that number? Oh, wonderful. Great. You see? Now the last question, a tricky one. Well, what is f of 5? You guys are so smart. Yep. F of 5 is 1 because f of 5 means when x is 1, what is the y value you see in the graph? So x is 5 here. The y value you see in the graph is actually here, 1. So you see, our limit does exist. However, the limit and the y value, they are not same. So when the limit and y value are not same, we say our function is not continuous. In order to have a continuous function, the limit and the y value must be the same number. So this function is not continuous. We are going to learn more about continuous in section 1.5 or something. Yeah. But right now, I'm just introducing you to the concept continuity. Any question? Or Auntie, are you saying anything? Sorry, I didn't hear you. Let me turn on my volume. So did you say anything, Angie? I see your microphone is on, but I actually can't hear anything. You didn't say anything? Okay, so any question from anyone about anything we did so far? No question? Let's see what do we have now. Limit rules. So all of these are just basic rules, okay? Here, the first one is saying if you add 2 functions and you're trying to take the limit of their sum, you can simply take the limit of that individual function and then add them. Okay, so limit of the sum of the function is sum of the limits. The second one says if you subtract 2 functions and take the limit, this is same as you're taking the individual limit and subtracting the second function, the second limit from the first limit. The third one says if you're multiplying a function with a constant and you're trying to take the limit of that, this is same as leave the constant alone and take the limit of the function. Then you multiply the constant with the limit and you get your answer. Same thing, the multiplication and division. The product of the limit is the limit of the product. Same thing, the quotient of the limit is the limit of the quotient. And then we have more rules. If you have a function with a degree with a power, you can ignore the power, take the limit of the function, and then apply the power on that limit. 7 says, if you have a constant, for example, y equals 1, or y equals 5, or y equals -7, whatever. Like if you have a constant for your function, a constant function, which is a horizontal line. So if you have a constant function, it doesn't matter where you're taking your limit, the y value will always be the same constant. For example, if you have y equals 1, it's this line. So this is the x, this is the y. So y equals 1. So it doesn't matter where you are taking your limit, anywhere in this function, your y value are the same number. The next one says, for y equals x line, wherever you are taking the limit, that x value is the same as the y value. And this is true because anytime you are going toward any number for the x, our y gives the exact same number because y is the x. The next one says the same thing with the power. So if you have x to the any power, it's same as that number with that power. And also radical. Any type of radical, basically you're substituting the limiting value and then take the radical of that number. If n is even, we assume that our limiting value is bigger than 0. Finally, if you have nth root of a function, you can insert a limit inside the root, find the limit, and then take the root of that function, that result, that y value. That would be your answer. So limit, you can move them around. You can, if you have a division, you can move the limit on the top, limit on the bottom. If you have a radical, you can put the limit inside the radical, find the y value, and then take the radical of that y value. So limit is very cool concept. Now, once we know the rules, now we can go ahead and evaluate some limits. So how do we evaluate limits? Step 1, always substitute. Whatever limiting value you have in your limit, substitute that into your function. Once you do that, then you have few choices. After substituting, if you get something valid, you stop and that's your answer, whatever you have. So it's an easy step. Substitute and then simplify. However, after substituting the limiting value, if you have a weird scenario, for example, like a number over 0, which doesn't exist, 0 over 0, which doesn't exist. So if you have something that is invalid, then you cannot substitute the limiting value. You have to first modify your function or simplify the function. And to modify or simplify, there are many rules, many tricks. One of them is like factor and cancel, or use conjugates to rationalize. Or if you're working with trig identities, then you apply trig identities and simplify. L'Hopital's rules, we are going to use it in chapter 2, not in chapter 1. Yep, for limit, we can use L'Hopital's rules, but not here, not in chapter 1. So depending on whatever function you have, you just use whatever tricks applicable, you use them, modify them, and then you re-substitute your limiting value into the new function. And then whatever you have, that's your answer. But if you find, if you face a situation where you cannot apply any of these, then all you can do is approximate with a bunch of numbers. Keep substituting a number that is closer to the limiting value into the function and observe your y values. See how y values are changing. Like the example we did in the very first slide today, sin x over x. Here, this one. See a bunch of numbers. You keep substituting them closer and closer and closer to your limiting value, and you observe the y values. But this is a headache, so we don't use them often. We usually use tricks to modify the function first. And this is for the last hope. We cannot modify anyhow. Now, for the same thing here, it's a diagram of what you're supposed to do when you face each situation. So first one, after substitution, if you get a real number, a valid number, you stop, that's the answer. Example, limit x is going to 3 of the function x squared. So when you substitute 3 into x, you get 3 squared, 9. 9 is a real number, valid number, so you stop. Our function, our limit is 9 for this function, when x goes to 3. You don't have to do anything. Second scenario, what if after you substitute at the beginning and you got a number on the top but 0 on the bottom? If you have a number on the top but 0 on the bottom, it means you're dealing with vertical asymptote. What is vertical asymptote? I'm going to talk about that in a bit. So when you're working with vertical asymptote, there are a few things you can do. First thing, again, if it's factorable, factor, modify, and then resubstitute. If it's not factorable, then you pick a number that is closer to the limiting value on the left side and pick another number that is closer to the limiting value from the right side. Substitute and observe their y values. So when you're dealing with vertical asymptote, the limits you get, they are actually infinity. Either you'll have answer as infinity or negative infinity. Vertical asymptote will never going to give you a number like example 1. In example 1, you'll get a number to work with. But whenever you're dealing with vertical asymptote, you're never going to get a number. You'll always get either a positive infinity in your answer or negative infinity for one-sided limit. But if you're working with exact limit, if the one-sided limit match with one another, then you have the answer positive infinity, negative infinity. If they don't match, then the answer will be doesn't exist. So vertical asymptote has three choices. Either you have limit to infinity or negative infinity or doesn't exist. Only three choices for vertical asymptote. And how do you know dealing with vertical asymptote? After you substitute the limiting value into the original function, if the numerator is a number but denominator is a 0, that means a vertical asymptote. And finally, the last scenario, when you substitute, you get 0 over 0. And 0 over 0 has many choices. You factor, cancel, resubstitute, or you rationalize, resubstitute. If you're working with trigonometry, apply trig identity, resubstitute. If you cannot do anything, approximate and observe the y values. So all these rules are mostly for 0 over 0. The vertical asymptote, either you use factoring or approximation, or both. Okay. Now let's do one by one. But before that, does anybody have any question? Does anybody have any questions? Sorry. Any question, comments, anything so far? No. Okay, so I'm going to explain and then we're going to do a few examples. So I'm going to do one example and then you're going to do the rest of the examples. So, limit in the simpler case. Simpler case, as it says, it's simple. You substitute, you get a number. That means you get a valid number, so you stop. So what is valid number? Either it's a real number or it's anything over a non-zero number. It's a fraction, okay? Or it's a 0, okay? So any number including 0 or any fraction, then you stop because it's a real number. For example, here, it says find the limit when x is going to 3 of this function. So step 1 is always substitute. Every x you see, you're going to substitute that with the limiting value. Here, our limiting value is 3. So I'm going to substitute all the x with that 3. So 5 times 3 cubed minus 3 times 3 square plus 3 minus 6. Let me know how much you have. Okay. So it's 5 times 125 minus 3 square is 9. 9 times 3 is 27. From here you get negative 3. How much we have total? Please do the calculation and let me know. Are you guys doing the calculation? You have your phones, right? Thank you. 595. So do we stop here after getting this number or do you have to go further? What do you think? Good job. Stop. It's a real number, so we are happy. Our life is simple. We don't have to do anything. Okay, now you try B and C. And let me take the attendance. Uh, okay, in order to take attendance, let me actually. Oh, I have it here. Oh man, I didn't save. Wow. Oh, probably this one. Oh yeah, I have it saved. Right. Okay, so when I call your name, please either write in the chat box or unmute yourself. Kimberly.
Here.
Great. Carrie.
Here.
Thank you. Judith.
Here.
Perfect. What happened to my Zoom? Mac.
Here.
Jihad. Ziad.
Here.
Chi.
Here.
Jocelyn.
Here.
Anjum. Anjum Khan. Anjum, are you there? No. Lucas.
Here.
Logan. Okay. Ellen.
Here.
Musfika.
Here.
Nicholas. Okay. Sanzim.
Here.
Sian.
Here.
Raka.
Here.
Ella.
Here.
And Hoa, you told me your name last time, but I forgot. Can you remind me again? What do you want me to call you?
You can call me Hoy.
Hoi? Oh, it's
Yeah.
Hoi, not Hoa. Okay, my bad. Thank you. And Andy. Yeah. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I have 19. Then how come I have 20 in my list today? So Hoi, did you just I called your name, right? Hoi?
Yeah, you
Hello?
called me.
Yeah.
But I'm also here. Sorry. Hello.
So wait, let me
Yes.
see who is talking. Yeah. So I have 2 Hoi.
My name is Hua, and like you can call me Apollo. I work for
Apollo.
Lec2.
Okay, so I have 2 of you guys. Right? No, or 1. So one name I see is Hoi Apollo Van, and another is Hua Yulam. Okay. I see. So Hoi is the female one. And Hua Apollo is the male one, right?
Yeah.
Okay, great. So one of them, I have only one of you in my register list. So let me see whom I have. Van, last name Van. I have you in my register list. So, boy, did you register late?
I think I recently transferred in. So that might be why I'm not on the roster.
Oh, so you're not officially in the class?
I don't think it updated yet.
Okay. I made the list yesterday. No, day before yesterday. So yeah, I have to recheck my list again. Not what? I have 20. I was thinking like, oh, I have 19 odd numbers. So if I had even number, that would be great. And now I have even numbers, 20 of you. Wonderful. Okay, so what do you have for B? 3/14? Okay. And for C, okay, for C, we have two choices, either 0 or undefined. Okay, that means let's do C together. So I think B is straightforward. You just substitute 0 to every x you see and then simplify. But in here, we are going to do the exact same thing. So we have x 3 times. That means we're going to substitute 0 3 times. So it's 0 times cosine to the 40 over 2 times 0 plus 5. So if you observe the denominator, 2 times 0 is 0 and 0 plus 5 is 5. And on the numerator, we don't even care what is cosine 0. Why not? Because 0 times cosine 0 is 1 actually. We don't have to care, but cosine 0 is 1 and 0 times anything is 0. So we have 0 over 5. So the answer is actually not undefined, it's 0. What it's saying you have $0. Now divide that $0 into 5 pieces. P-I-E-C-E, 5 pieces. Well, if you start with nothing, it doesn't matter how many times you divide your nothing into, you still have nothing left. So the answer is nothing, which is 0. When it's undefined, it will be undefined when you have a number on the top but 0 on the bottom. For example, if you have 5 over 0, it means you have 5 candies. 1, 2, 3, 4, 5. You have 5 candies, divide them into 0 pieces, which is impossible. When you already have something, that's it, you have it. You cannot make it disappear unless you're a magician. Even magician, they cheat. They don't disappear things, okay? So dividing something into 0 pieces is not possible. That's why this thing is undefined. It doesn't exist. But dividing 0 into many pieces is possible. So the answer is 0. Any question? No question? Okay, so you're done with the easy case. Now we are going to the, so the answer is 0. Yes, the answer is 0 for C. So let me actually erase this so that you don't get confused. Now the second scenario. What if you substitute and you get number on the top and 0 on the bottom? That means you're going to work with vertical asymptote. So what is vertical asymptote? Vertical asymptote of a graph is a vertical line that where the graph tends toward positive or negative infinity as your x value approaches to that particular number. What does that mean? You will have a vertical asymptote if you go toward a particular x value, let's see your y value to become extreme. Either it's extremely positive or extremely negative. In that case, you have vertical asymptote. So that's why your limit at vertical asymptote will have three choices. Either it's positive infinity or negative infinity, or the limit doesn't exist. Three cases. And I have an example here. Yep. For example here, this is our x value 0. Now, when you walk toward the x value from your left side, so you're doing one-sided limit from the left side. What is the left-sided limit when you walk to 0 from the left? So you're walking to your graph from the left side. When you walk, observe your y. It's going bigger, smaller, and smaller, and smaller, and smaller on the y direction. So it will never going toward a particular number. Look at the y value. It's getting smaller and smaller and smaller and smaller. It will go on forever and ever and ever and ever. Okay. So since our y values keep going on forever, so the left side limit of this function is negative infinity. Similarly, if you walk to 0 from your right side, so this is right-sided limit. When you walk to your x value 0 from the right side, it means you're walking on the function from your right side. And look at the function, the y values. They are getting bigger and bigger, bigger and bigger and bigger and bigger forever. So this function is never stopping anywhere. So our vertical asymptote is here because vertical asymptote makes our graph into pieces. It separates our graphs into pieces, different pieces. So when x is 0, we don't have any valid y value. On the left side, our y values are getting smaller and smaller. On the right side of the 0, our y values are getting bigger and bigger and bigger and bigger. So that's why the right side limit is positive infinity, while the left side limit is negative infinity. That's why exactly at the limit, exactly at 0 of this function, the limit doesn't exist because the left side limit is one number, the right side limit is another number. They are not same. Since they are not same, so exact limit doesn't exist. So the limit we have at the vertical asymptote at this point, it doesn't exist. On the other hand, the next function is 1 over x squared. Now 1 over x squared, if you walk from your left side towards 0, you have this portion of the graph. So this is our x value 0, and we are walking towards 0 from the left side. So on the left side, we have this function, this piece of the function. So when you walk on the function, observe your y value. It's getting bigger, 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 bigger. It's going bigger and bigger and bigger and bigger. So the biggest number we are going to get from here is infinity. So left side limit is infinity. Now, what is happening on the right side? If you walk from your right side toward the x value 0, and you're observing the y values, your y values are going where? They're also going toward infinity, right? Great. Now, in this case, what is the exact limit at 0? Wonderful. It's infinity this time because our left side and right side gives the same y value. They're not a number. Well, we don't care as long as they're giving us the same thing. So if you have the same thing, the limit is that thing. But if you don't have the same thing, the limit doesn't exist. So vertical asymptote will never going to give you a number. They will always give you three things, one of the three things. positive infinity, negative infinity, or doesn't exist. Clear? So what is vertical asymptote? Vertical asymptote is a certain x value that divides the graph into pieces. And the y value doesn't exist because the denominator is 0 for that x value. Okay, well, I have a blank page, so let me take it out. Now you know what is vertical asymptote. And let me just introduce you a little bit about vertical asymptote, like a little bit. Vertical asymptote. So how do we find vertical asymptotes? We don't need it here, but we need it for later sections. Finding vertical asymptote. To find the vertical asymptote, we don't have to do much. First thing we're going to do, if it's factorable, we are going to factor our function, top and bottom. If it's cancelable, we are going to cancel whatever we have in common. And then we have a new function, new simplified function. So from these two steps, we are going to get a simplified version of the function, simplified f of x. Now, that simplified f of x, we only care about the denominator. Set the denominator of the simplified f of x equals 0 and solve for x. That's the vertical asymptote. X equals something, some number. Okay. What makes the simplified function's denominator 0? That's the vertical asymptote. And when you have a vertical asymptote, the limit at the vertical asymptote will always be either 1 of the infinity or dn doesn't exist. So we are going to learn a little bit more about this later, or you're going to do more example on vertical asymptote later. But right now, I'm just telling you what is vertical asymptote and how do you find it from a function. Now, what are the steps to find the limits of the vertical asymptote or near the vertical asymptote? Like I said before, we don't have much options. We have only two options. Either we simplify the function and then we resubstitute the limiting value, or sometimes you have to do both, sometimes you have to do one of them. And then if you get a real number after resubstitution, you stop, that's your limit. And if you don't get a number, that means pick a y value from both sides of the limiting value and observe their sign. Positive sign means you're going to get positive infinity. If you have a negative sign for a number for y value, that means you're going to have a negative infinity. And if the left side limit and right side limit doesn't give you the exact same thing, then we say the limit doesn't exist. But if you have the same infinity sign or negative infinity sign, that means the limit is at the infinity or negative infinity. Now let's do some examples, some fun examples. It says, what is the exact limit at x equals -9 or when x is going toward -9 of this function 6x plus 54 over absolute value of x plus 9? It looks simple, but just because we have absolute value, this actually is not so simple. Now, absolute value, when you pull it out, it has two choices. Either it's a positive number or it's a negative number. We don't know. That's why we have two scenarios to deal with here. So what you're going to do is, in order to find the exact limit, you can substitute first. So when you substitute this, you see what we're going to get. We get 6 times -9, which is -54, and we have +54. On the bottom, we have -9 plus 9. So that gives us 0/0. Oh man, I picked a bad one. This is actually an example of 0/0. But anyway, actually, let me leave it now. Let's take a look at particle asymptote. So we are going to come back to it, okay? This is the example of 0/0, but I want to do 0/0 after we introduce you to particle asymptote. I didn't realize this before. So we're going to do it. We're skipping for now. Now, if you look at, do you have the same problem here? Let's see. Point is substitute -1 here. We have -1 square minus 4 times -1 plus 3 and -1 square minus 1. So -1 square gives us 1. And how about in the middle? What do we get in the middle? -4 times -1. Do you get a +4 or do you get a -4? Come on, guys, I'm asking you a question so that you can reply me. Thank you. It's +4. So we have 1 plus 4 plus 3. And what do we have on the bottom? 0. So we have 5, 7, 8/0. See? A number over 0. That means x equals -1 is actually a vertical asymptote. Okay? So you're dealing with a vertical asymptote. So we have 2 scenarios. First, we are going to simplify if it's possible. So my question is simplifying possible here? Limit x goes to -1. Can you simplify this function anyhow? What do you think? Yes, wonderful. How? Using factoring. Perfect. The denominator is a difference of 2 perfect squares. So what are the 2 factors we have on the denominator? X plus 1, x minus 1. So if you forgot your difference of squares, the difference of squares, let's see here, x squared minus y squared. The difference of squares is take the basis only, add them, subtract them. So x plus y, x minus y. In our case, it's not y, it's 1. So it's x plus 1, y plus 1. So x plus 1, x minus 1. Great. How about the numerator? Can you factor? Oh, Ellen is super fast. Ellen already factored the top. So 2 numbers multiply to 3 combine to -4. X minus 3, x minus 1. -3 times -1 is +3, and -3 minus 1 gives us -4. So 2 conditions fulfilled. We factor the top, factor the bottom. And then what do you see? What do you observe? They cancel. See, we have x minus 1 on the top, x minus 1 on the bottom. We can cancel them. So we left with x minus 3 and x plus 1. And now we resubstitute. So our limiting value is -1. So we resubstitute and see what do we get. We have x minus 3. Oh, sorry, my bad. We have -1 minus 3 over -1 plus 1. And now what do you see? we have negative 4 over 0, which doesn't exist. So we have two choices here. Either we accept the fact that the limit at -1 doesn't exist, or we can recheck, or we can check a different way to see whether the limit really doesn't exist or not. Okay, so since we are doing it for the first time, we should recheck with a new process, with a new procedures, that whether limit at -1 really doesn't exist or not. So what we're going to do is we're going to pick a number left of -1 and right of -1, but very close to -1. For example, so -1, let me see. We have 0 here, -1 here, -2 here. So we want to see a number that is very close to -1 on the left and very close on the right. Great, Ellen. Yep. So let's say for the first one, we are picking, so we are looking at one-sided limit. So let's say on the left, we have negatives 1.1. Okay. And for the right-sided limit, let's say x is negative 0.99. The limit x is going to -1 from the left side of x minus 3, x plus 1, and limit x is going to -1 from the right side of x minus 3 over x plus 1. Now, if you pick -1 over 1.1, I did a space here, so let me do it actually here. So we have -1.1 minus 3 over -1.1 plus 1. And for the bottom, we have -0.99 minus 3 over -0.99 plus 1. So we have negative, negative, we get a negative. On the bottom, 1.1 is bigger, but it has a negative sign, so we have a negative. Negative, negative gives us positive. So our left side limit is positive infinity. How do I know? Because it's a vertical asymptote, and vertical asymptote always gives us infinity as a limit, not a number. Now, if you observe the right side limit, negative, negative, we still have a negative because we're adding two negatives. And on the bottom, 1 is bigger, but it has a plus sign, so it's plus. So we get a minus. Minus means it's a minus infinity. So plus means it's a plus infinity, and minus means it's a minus infinity. So look, the left side limit is positive infinity, but the right side limit is negative infinity. That's why the limit actually doesn't exist. So we are correct. Once we resubstitute after modifying, we got the result is undefined, and here it's truly undefined. Okay. So since we did it for the first time, so we check both ways. First, we calculate the limit, and then we checked it using estimation. But if you keep doing more work, more examples, eventually you'll see that most of the time when we get DNA doesn't exist, it's actually true. Most of the time. Unless you made a mistake somewhere. Any question from anyone? Any comments? Please don't be afraid of asking me questions if you're already feeling lost so far. I would love to hear your questions. Questions? Comments? Complain. Does anybody have any complaint? No? Thank you, Mastika. Okay, then you try this one and the next one. And do I have more? Yeah, I have more fun example. So try doing this. And then I have one more, the same type. I'll actually write this down here so I don't have to keep flipping them. Limit x goes to 1, x plus 1 over x minus 1 square. So do both of them. Let me know when you are done. You don't have to stay unmute if you want to have a conversation. You can so you don't have to stay muted. You can unmute yourself and you can talk. Question? Are you guys done? You're finding the limit, but in order to find the limit, you have to use one-sided limit because both of them are particle asymptotes. You're looking at the limit at the particle asymptote. Oh, I forgot to tell you. So today is Monday, right? So our class Wednesday, it will be in person. It will be in the North building, on the basement, room number 107, if I'm not wrong. North building, room number 107, in the cellar. It's C107. C means basement, it's the cellar. So I'm very excited to see you guys in person. Day after tomorrow. Try not to be late. Are you guys done? If you are done, please answer write on the chat box or unmute yourself. Okay, Apollo still needs time. No problem. Oh, you guys are sending me direct messages. I'm actually viewing the messages from another computer. So direct message. Okay, Musfika is done. Sanzim is done. Okay. Andy. Okay, everybody's done. Great. So, who would like to tell me the first step? What is our first step to find any type of limit? What do you do first? Substitute. Wonderful. So let me erase this because I have it on the next page. Oh, let me do the substitution here. We have -8, so we are going to substitute twice. -8 plus 7, -8 plus 8. So we have 0 on the bottom, -1 on the top. So we have a number over 0. That means we are dealing with a vertical asymptote. So our limit will be either 1 of the infinity or doesn't exist. It's not going to give us any number. So we are done with substitution. We know we are dealing with vertical asymptote. Then what do we do? What is our next step? Great. Since the vertical asymptote, so we pick two numbers very close to -8, one on the left, one on the right. So we do left-sided limit and right-sided limit. So limit x goes to -8 on the left side, and limit x is going to -8 from the right side of this function, x plus 7, x plus 8, x plus 7, x plus 8. Now you can pick any number. Sanzim picked -8.1 and -7.9. So if you're confused about which one is left, which one is right, we have -7, -8, -9. So left-sided limit means here we are picking a number here, anything. So it's -8.1. So -8.1 plus 7, -8.1 plus 8. That gives us -8.1 is bigger than 7, but it's negative. So we have a negative on the top. -8.1 is bigger than 8, but it's negative, so we have a negative on the bottom. So we have negative over negative, which is positive. That tells us we have a positive infinity on the left side. So our graph is going this way on the left, positive infinity. On the right side, we are picking -7.9. So -7.9 plus 7, -7.9 plus 8. Now -7.9 is bigger again, but it's minus. So we have a minus on the top, and on the denominator 8 is bigger, and 8 is a plus sign. So plus is bigger. Minus and plus gives us a minus. So we have a negative infinity as our answer on the right side limit. So negative infinity means our graph is going downward. So on the left side, the graph is going upward. The right side, the graph is going downward. As a result, the exact limit at -8 of this function is what? One limit is negative infinity, other limit is positive infinity. So the limit doesn't exist. You know the trick? Let me tell you the trick. The trick to verify your answer is if you can remember one thing. If the denominator has a power of 2, then the limit will exist. But if your variable has a power of 1, then the limit doesn't exist. In other words, if your if your factor has an even power, the limit actually exists usually. And if the factor doesn't have an even power, then it doesn't exist. Usually, not always, okay? Now, in here, if we apply my rule, we have a 2 power on the top. That means our limit will exist. Either it could be positive infinity or negative infinity. I could be wrong, but as far as I remember. So it is the same thing. We substitute. Can you repeat what I said? Okay. So we have a rule. I actually don't remember about the numerator. What we're supposed to have on the numerator. The denominator, if the factor on the denominator has an even power, then the limit is either infinity or positive infinity. But what do we have to have on the numerator? I actually don't remember that rule. So we consider both numerator and denominator. By comparing numerator and denominator, if the denominator factor has an even power, the limit exists. If the denominator factor doesn't have an even power, the limit doesn't exist. Something like that. I don't quite remember the exact rule because I didn't do it for a long time. Anyway, so we have 1 plus 1 over 1 minus 1. So 2 over 0, vertical asymptote. And here we have nothing to simplify. So we have to do the same thing what we did in the left page. Substitute. So we have to look at one-sided limit. Limit x is going to 1 from the left side, and limit x is going to 1 from the right side. X plus 1 over x minus 1 square. X plus 1 over x minus 1 square. One thing you always see is that because of the square power, our denominator actually will always be positive, regardless of what number you pick, right? Because you are squaring the quantity. So if you have a plus square is plus. If you have a minus in the quantity and square the quantity, you still have a plus. So since you have a square on the top or square on the bottom, our denominator is always positive. It doesn't matter what number you pick. Now you're going to 1 from the left side. So we have 1, 0, and 2. If you're working 1 from the left side, it's smaller than 1. So let's say 0.99. 0.99 plus 1 gives you plus over plus. So we have positive infinity. Now you're picking a number from the right side of the 1 for the right side of the limit. So let's say 1.1. So 1.1 plus, what's wrong with my pen? 1. Oh man. 1.1 plus 1, that gives us plus over plus, which is again infinity. So the observation I mentioned before, it actually worked here. Our denominator has an even power, so our limit does exist here. The exact limit at one of this function is the same limit infinity. Is anybody lost yet? Did I lost anyone? No. Thank you for the feedback. Wonderful. I think I'm going to like you guys a lot. So if you have a question, if you feel lost, please don't hesitate. Okay, I'm here to help you. I know many people don't like online, but I want you to feel as comfortable as possible and think of it as an in-person. So if you can ask me anything in person, don't hesitate to ask me in here. I would love to answer your questions. So any question from anyone so far? No? Then one fun question, try doing it by yourself. Find a function. You don't have to write down the function. You can sketch a graph. Sketch a graph of a function with these three scenarios. When you walk 0 from the left side. When you walk 0 from the left side, your y value is 1. When you walk to 0 from your right side, your y value is 2. But exactly at x equals 0, your y value is -1. Try to sketch a graph. Yep, Sunzim, it's similar to that. It's a piecewise function. When you walk from the left side, your y value is 1. When you walk towards 0 from your right side, your y value is 2. But when you're exactly at 0, your y value is -1. What could be that function? It's an interesting question. It's a fun question. It's about how you can visualize the scenario. And I have more piecewise function. So did you guys come up with the function, come up with a graph with these three scenarios? Oh, Sunzim already did. It's Sunzim, right? I remember last time we said sun.
Yeah.
Yeah. So 0. So let me do this. We have y value 1, y value 2, and y value -1. And our main center of this graph is about 0, around 0. It's hard to explain, but Sanzim, would you like to explain your graph? Like you can give me the direction now and I will draw it. Oh, actually you can draw it on my thingy screen. You see there is the option says annotate on the top.
On the top.
Yeah, on the top or on the left side somewhere. It's a pen, some type of pen.
I don't think I see one. I could just explain it.
Okay, then go ahead.
Okay, so from the first one, when it says the limit as x approaches 0 from the left side equals to 1, basically, on the left side of the graph where the negative x values are, you could like make a curve that like points to the y value of 1. So that would represent for that specific limit.
So something like this.
Yeah, something like that.
And what would be the end? A hole or a closed circle?
It'll be a hole.
Hole. Okay.
And then for the limit as x approaches 0 from the right equals 2, you basically start from the right side of the graph where the positive x values are, and then it touches 2 with a hole. And then as x equals 0 equals -1, when you go to -1, the y value of -1, you put in a filled in circle.
Wonderful. You got the idea perfectly. So left limit when you're walking on the left side, it's 1, but it has to be whole because it doesn't have any y value there. How do I know? Because the last one says when x is 1, x is 0, our y value is -1. That means for the other two limits, it's a whole. So when you walk from the right side, it doesn't matter what type of graph you draw. I just draw a normal curve. When you walk from your right side, we have y value 2. But when our x is 0, our y value is exactly -1. So it's a jump and a hole at the same time. Okay. Any question here from anyone? No question. So you don't have to actually draw the arrow. I drew the arrow for you to understand easier way. Okay, I see private message. Do you make the graph or the equation? No, the graph, because making an equation is harder, but making a graph is easier. So many of the questions we did in class, you're going to see very similar questions in your homework. So explore your homework on 1.3456. And now I'm giving you a choice. Do you want to start new information, or do you want to quit here? Do you want to leave here today? If you feel overwhelmed, we can stop here. But if you're enjoying this class, I can keep going on for 7 more minutes. We still have 7 more minutes, right? We have class answer 20, 7:20. So what do you think, guys? Do you want me to keep continue the new topic or stop here? Continue? Great. So you have 7 more minutes to learn new stuff. Wonderful. You guys are really remarkable. If I were you, I would have said, stop, stop. But you guys didn't do that. Thank you. Okay. Now, limits for piecewise function. We already seen few piecewise function. For example, this one on the left is a piecewise function. All these examples we did, they're all actually different pieces. They're not piecewise exactly, but they are pieces in one function. The difference between these questions and the piecewise function is that in piecewise function, we draw many different functions in one graph. But the examples we did so far, they have one function divided into different pieces. Okay, that's the difference between piecewise function and having a vertical asymptote. Vertical asymptote still has one function, but piecewise function doesn't have one. It has many different functions, just pieces are glued together on the same plane. So one of the piecewise function is example here on the right side. And to find the limit of the piecewise function, for the limit of the piecewise function, we are not going to have infinity. We may have infinity, but not always. We are going to have a real number here. So piecewise function gives us limit real number or doesn't exist most of the time. Maybe there are rare cases when you have infinity, but so far I read whatever in the book, I didn't see any example. So probably we don't have any example in this class. So in this class, when you're working with piecewise function, you have only two choices for your limit. Either it's a real number or the answer doesn't exist. Why not? Because the left limit and the right limit doesn't exist. That's why. So the left limit and right limit are not the same number. For example, here, it says find the limit, the left limit at 2, the right limit at 2, and the exact limit at 2. So in here, the story is this. We have two pieces. One piece is y equals x squared minus 3. It's a parabola. And we have a second piece, y equals x minus 3 over x minus 3 squared. It's some type of rational function. Okay, something like this. So we have two different types of function, okay, not one function. Two different types of function we are drawing on the same plane. One of the function is before 2, the other function is after 2. So the first one says left side limit. So in the left side limit, we are going to see before 2 which function we have. So which of the function we have before 2? The square function or the rational function? The part 1 or part 2? Before 2, which function we have? Part 1, great. See the domain, it says for all the x values smaller than 2. Means all the numbers that is smaller than 2 for the x, our function is this one. So for the left side limit, we are going to use that function. X squared minus 3. So limit x is going to 2 from the left side, this function. And then we don't even it's a one-sided limit, but it's a piecewise function, so we don't need any number to estimate. We can directly estimate this number and see what do we get. So we get 2 square minus 3, that gives us 4 minus 3, which is 1. So on the left side, this piecewise function has a y value 1 that are going closer to 1 for all the x value going closer to 2. Now in the next one, it says go to the function that is on the right of 2. Right of 2 means all the numbers that is bigger than 2. So for all the numbers that is bigger than 2, we have this function. So we have limit x is going to 2 from the right side of the function x minus 3 over x minus 3 squared. Now, what do you observe in this function before you go any further? Do you observe something? We can cancel. It's actually already factored. We can cancel the top factor with one of the bottom factor, and you're left with 1 power. So this is same as limit x is going to 2 from the right side of 1 over only one of them left on the bottom. So we could simplify one piece. The first piece we couldn't simplify to just a simple square function, but the rationale we could simplify, so we did that. And now we are going to substitute again. I mean, we are substituting again for the second piece. So we have 1 over 2 minus 3, that gives us 1 over negative 1, which is negative 1. So our right side limit, right of 2, the limit is negative 1. Left of 2, the limit is positive 1. What does that tell us? What is the exact limit exactly at 2? DNA, it doesn't exist. See? Because left limit is not same as the right limit. So the rule applies same. There's a jump, that's why. The same rule apply. We have look at the left limit, right limit. If they are same, the limit is the same. If they are not same, the limit doesn't exist. So the difference between the vertical asymptote example and piecewise function is that vertical asymptote will always give you infinity or DNA, but piecewise function will give you a number or DNA. So here one-sided limit was number and the exact limit doesn't exist. So in our next class, which is Wednesday, which will be in person, I'm going to start with another piecewise function. And then we are going to do the third scenario where we have, oh, what happened? Cool, I didn't know you could do that. Wow. And then we are going to go to the third scenario when you have 0 over 0. And then whatever example we missed here, the first example, I'm going to put that under that option. Okay. And I recorded this lecture. So if you could not keep up with writing down all the notes, please rewatch it and then write down all the notes. Okay. And once I'm done with organizing all of them, I'm going to post not the solution, but the outline of the note on Brightspace. Okay. So goodbye, everyone. Have a good night. See you all Wednesday. Bye-bye. Thank you so much for your participation. Bye.
Will the recording also be posted on Brightspace?
Yeah, so if you go to class recording link, you will see there's a link says class recording. You click on it and then it will take you all the classes.
Okay, and will the homework also be posted there?
Homework will be on Lumen. So Brightspace is under CUNY, but for homework you have to go to Lumen.
Okay, I was having some trouble logging into it. So when is the first homework going to be due?
Next week.
Okay, so I'll probably be able to log in by then. Thank you.
And maybe you couldn't log in because I changed the I opened a new account and I closed the old one. So did you sign in the new account?
Yeah, I haven't been able to sign in like any account.
Then you can show me in our next class Wednesday.
Okay,
And I
I
can
will
see
do
what
that.
is
Thank
happening.
you.
Okay. Bye.